Alright, today we're going to talk about our last section for Chapter 9. There are a couple more sections in the textbook. We are just not going to talk about them. We're going to stop with our idea of testing, doing hypothesis testing on means. So we just spent Chapter 8 talking about hypothesis tests, and as we were going through those hypothesis tests, we were using them for testing different claims about population proportions. Now in this section we're going to do a hypothesis test for population means. We're going to use our same procedure. Right, we're going to start by stating our hypotheses. The difference is our hypotheses are going to have a mu instead of a p. We're going to prepare. Choose a significance level, a test statistic, check our conditions and assumptions, just like we did back in Chapter 8. Do our computations. Again, we're going to rely pretty much solely based on Statcrunch to do these computations. And then we're going to make an interpretation or decision at the end. Do we reject the null hypothesis or do we not? What does this mean? How do we want to answer our final question in the end? All right, so down at the bottom of this first page is just an example of a table. Looking at this table, again, it shows the differences between our hypotheses from what we saw in Chapter 8. In Chapter 8, we had p equal to some value. We're just going to look at, instead of p, we're using mu. We're looking for a population mean. So our null hypothesis still always has an equal sign, so mu is going to be equal to some number. Our alternative hypothesis could be a not equal to. That would be a two-sided test, and then our one-sided test would be a greater than or less than. Again, we're going to use context clues and keywords in our problem to determine which pair we want to use for our hypothesis tests. All right, so before doing these, we are going to check our conditions. Again, first one, make sure our sample is random and independent. Almost always holds. We're just looking for the word random somewhere in our sample. A large sample, just like we saw in the last section, either the population distribution is normal or the sample size is large enough, at least 25. A large population, again, we're not going to worry about doing the calculation. This one is almost always true. So we're just going to be kind of skipping condition 3 in this last section, again, just to kind of speed up our process a little bit. All right, so the next thing we see on this page is a formula for our t statistic. So this is going to be something that we could calculate. Again, this is similar to calculating a z-value like we saw in previous chapters. We're not going to worry too much about doing these calculations because we're going to be doing our hypothesis testing solely in Statcrunch for this section. So I put this formula in there just for reference. That way if you want to take a look at it, compare it to some different things, we're not really going to be using too much or at all as we're going through these problems. All right, so down at the bottom are steps for Statcrunch. Just like we did in section 9.3, we're going to use our t-statistic test for section 9.4. So we're going to go into stats, we're going to select t-stats, one sample with summary. Right, we're going to enter our mean, our standard deviation, and our size. Select the null hypothesis, enter our null and alternative hypothesis. And then as we're doing these, we want to make sure that when we're putting these in there, that we are going to enter our mu naught value. So we are going to have to enter a number, right, when we're doing our hypotheses, and that's going to be the mu sub 0 that we're going to see in our list of kind of information on the next page. So just kind of keep that in mind. Again, very similar to what we saw in the last chapter, very similar to what we saw in Chapter 8. The big difference, we're doing a t-test and not a z-test. Okay. All right, so let's walk through a couple of examples from beginning to end. In 2010, the mean years of experience among a nursing staff was 16.3 years. A survey of a random sample of 35 nurses at the hospital found a sample mean of 18.37 years with a standard deviation of 11.12 years. Do we have evidence that the sample mean years of experience among the nursing staff of the hospital has increased? Use a significance level of 5%. All right, so we're going to start by listing everything that we know. Okay, so our population is going to be all nurses, right, among this nursing staff. Our sample size, right, is 35 nurses that were sampled. right? Our mu naught, right? That's going to go up to our previous mean, right? So that's going to be our 16.3 years. So our mu naught is like our claim, right? What are we testing against? So we're testing against this value of 16.3. Right? Now this X bar and this S, right? That's from our sample of 35. So that's going to be our 18.37 years, right, with a standard deviation of 11.12 years. Okay. Our degrees of freedom, again, we take our sample size minus 1, which gives us 34. If we were doing more of these calculations by hand, we would be using our degrees of freedom. We're not necessarily going to use this value as much this semester as I do usually in my courses, because we're not going to do any of these calculations by hand. We're just going to use Statcrunch. Our level of significance, alpha equals 0.05. Okay. All right, what we want to know, right? Do we have evidence that the mean years of experience among the nursing staff at the hospital has increased? So we're going to say, has the mean increased? Right. Increased meaning we're going to use a greater than symbol. Okay. All right, so then we're going to start our hypotheses. Our null hypothesis. Again, both of these we're starting with mu. And we're using this mu naught value that we have here. So mu is 16.3. Okay. And our alternative hypothesis is that in this case we're asking if it's increased. So we're going to say mu is greater than 16.3. Okay. To check our conditions, our sample is random and independent. Yes. Our sample size is 35. 35 is greater than or equal to 25. Yes, that's true. Large population, we're skipping that, so our conditions are done. All right, so we're just kind of shortening the process as we get to the end of the semester. Again, there's a couple of questions in previous sections where you might have to specifically check the conditions. So if you are asked to in the homework on my stat lab, make sure you do so. Otherwise, a quick check looking at our sample size is generally what we're looking for. Right. Now we are going to compute to compare and find and interpret our value using Statcrunch. Okay, so like we did in the last section, right? When we're working through Statcrunch, we are going to go into our t-stats, right? And then we're going to enter our x bar, we're going to enter our s and our n, right? So our sample mean, our sample standard deviation, and our sample size. The other thing we want to make sure we enter, right? We want to make sure we select our sign appropriately, and what we are testing, right, is that we want to make sure that we select, right, the greater than or equal to sign, and that we put the value, this mu naught value of 16.3 in there in our set of hypotheses as well. Right? So we want to make sure that those are being selected correctly. After we select the compute button, our t value, again we're getting a t instead of z, is going to be 1.10. Right? And then we also get a p value, our 0.1398. Right, and then just like we did in chapter 8, we're going to compare this p value to alpha. Right? So p is 0.1398. Right? That is greater than alpha, which is 0.05. P is greater than alpha. Right? P is greater than alpha means we do not reject our null hypothesis. Right? So we are asked, do we have evidence that the mean years of experience among the nursing staff at the hospital has increased? We're going to say no, we do not have evidence that the mean experience among the nursing staff has increased. Right. So going back up, kind of marking our paper as I did previously, we do not have evidence to reject our null hypothesis, right? So they could be equal, right? We don't have evidence to say that they have increased. So again, P was greater than alpha. We did not reject our null hypothesis, so no, we do not have evidence that the mean experience among the nursing staff has increased. Right, let's look at one more example of a hypothesis test. In the 2010 season, average home attendance for NHL hockey games was 17,072. Suppose a sports statistician took a random sample of 30 home hockey games during the 2014 season and found a sample mean of 18,104 with a standard deviation of 1,203.5. Can we conclude that the mean attendance at NHL games has changed since the 2010 season? Use a significance level of 5%, 0.05. Okay. So our population is going to be all NHL home attendance. Right. Our sample size, right, is 30 games that were sampled. Right. Our mu naught from our original claim, right, from 2010, 17,072. Significance level, alpha equals 0.05. Right, our X bar is from our sample. Our sample mean, 18,104. Our sample standard deviation, 1,203.5. Our degrees of freedom, again, we're taking our sample size minus 1, and we get 29. Okay, so what we want to know, has the mean changed? Right, and remember, anytime we see the word changed or different, right, we're thinking about not equal to. So our null hypothesis, mu. Mu is equal to 17,072. Again, we're using our mu naught value. Our alternative hypothesis, mu does not equal 17,072. Okay. All right, our conditions. Our sample is random and independent. Yes, we're told we took a random sample. 30 is greater than or equal to 25. Yes. Large enough population? Yes. Right, now we're going to compute to compare using Statcrunch. Again, we're using our T statistics. Right, we're going to enter our X bar, our S, our N, and then in our hypothesis testing part, we want to make sure we select the not equal to, and we want to make sure we put the 17,072 in there. That's our mu naught value. All right, our T that we get is 4.70. Our p-value is less than 0.0001. Okay, so P, right, is less than 0.01. That's clearly less than alpha. Right? So since P is less than alpha, we are going to reject our null hypothesis. I got to move my paper down here. All right, so we're going to reject our null hypothesis. So we're going to cross off our null hypothesis up here. All right. So that means, right, if we rejected our null hypothesis, then our alternative hypothesis is most likely going to be the true one. Right, so our question, can we conclude that the mean attendance at NHL games has changed? We're going to say yes. Evidence suggests that the mean attendance at hockey games has changed since 2010. Right, so as we're working through section 8.4, again, what we're looking at and what we're thinking about hypothesis tests. As we're going through these problems, again, remember we're not using z values, we're using t values. So we want to make sure we choose those appropriately in Statcrunch. Our condition checking, our types of answers, whether we reject or we don't reject our null hypothesis, is still the same that we saw back in chapter 8. Again, the only difference is here we're using mu's. We're talking about means instead of talking about our p's or our proportions.